Right. Oops. Huh? All right. I think this lesson will be quite easy for you. And some of you might have even seen it before. Has anybody seen Pascal's Triangle before?
Yes.
You have, yeah. You've seen it before? Yeah, well, do you know how to make the triangle? Well, before we do that, actually, I'll give you couple of small problems to write down. I want you to write down what x plus y power 0 equals, x plus y power 1 equals, and x plus y squared. I want you to expand these. Just give you a minute. Yeah, you got them? Did you write them down, what they're equal to? Write them down. Because I'm going to show you something visual now with it in a moment. Yeah? Right, so what is x plus y power 0? 1. 1.
Yeah,
1. And x plus y power 1 is 1x, yeah, plus 1y. Yeah. And then x plus y squared is 1 x squared plus 2xy plus 1 y squared. And I'll do one more for you. X plus y cubed will equal 1x cubed plus 3x squared y plus 3xy squared plus 1, try again, y cubed. Now, what I'm going to do in a moment is I'm going to copy those. Actually, what are those numbers called? No, the numbers. No, just the numbers. What are they called? The red numbers. Yeah, what is it? Coefficients. So I'm going to copy these coefficients down. Before I do, I'll just let you write that down if you need to. Are we just missing sun? Yeah, just sun, isn't it? Well, what are we going to do for Coke Zeros now that he's not here?
Sun.
Okay, did you write that down? Yeah. Now let me copy the coefficients down. So what was the first one? It was 1, and then we had 1, 1, 1, 2, 1, 1, 3, 3, 1. Yeah? Now the next one, some of you know what it's going to be. 1, 4, 6, 4, 1. Yeah? And the rule here seems to be that if you add two numbers together, you can get the number that goes under it. So for example, you start off by writing down nothing and 1 is 1. And nothing and 1 is 1. And then 1 and 4, 5, 10, 10, 5. And back to the 1 there. Yeah, I'll do another row, okay? So, nothing here, and the 1. So if you like, you can think of as if there was a 0 there nearly. So, nothing and 1, 1. 1 and 5, 5, 10, 10, 10, 10, 5, 5, 1, 1 and nothing. See how this is going? The pattern? Yeah. This is called, well, not yet. Pascal's Triangle. Now, just a bit of naming here. This is called row 0, actually. Yeah. For example, this one, if I jump down, this one would be called row, what one would that be called if that one's 0? 4. But there's a quick way. You just look at the second number. It gives you the row number. So this one here is going to be called row 6. Yeah? There's also something interesting about okay. How many? A lot of you want to do computer science, don't you? So maybe those people who have an interest in computer science, maybe one of you can tell me if you've ever heard of this idea, checksum. Anyone heard of that before? You know checksum?
I know some.
You know some. Good. But do you know checksum? Not too far away. Not too far away. Does anyone know checksum?
Maybe it's called pre-sum.
No. We only call checksum. Does anyone know what it is? No? So in computer science, when you have data, you would like to check if the data is corrupted, broken, or not. You know, sometimes on your computer you can't open a file. It says file is corrupted. Yeah. That means the file is damaged. But how does the computer know it's damaged? It does something called a checksum. So in your computer data, I'll give you a quick example. You know, if you have your information like 0, 1, 1, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Well, let's just say that's a bit of data. Your data is normally in groups of 8 bits, 8 zeros and ones. In every string of bits, the number of ones is always even. So how many ones do we have here? 4. So the computer says that this file is okay. But if one of these, say that was a 0, then the computer checks this, and is it okay? It knows it's corrupted. The problem is, it doesn't know which piece is the broken piece, because it doesn't know which one of these is wrong. It just knows that it was expecting an even number of ones, and it didn't get that. So then it won't let you use this file, because it knows there's something wrong with it. You can actually do something similar with Pascal's triangle. You can check that you've done a calculation of the row correctly, because there's something special when you add up the row. So if you add up 1, you get 1. Fine. If you add up these 2, what do you get? 2. Add up these? 4. Oh, I'm starting to see something now. Add up these? So what do you think this should be? 16, and this one should be 32, and this one should add up 64. So the total sum should be 2 to the power of the row number. So in other words, this should equal in total 2 power 6. And this is what you would call like a checksum. It's a way to know if you calculate it correctly. Because you understand, of course, if you made one small mistake here, suppose you wrote the wrong number here, then on the next row, which will be wrong? Which numbers would be wrong on the next row? The 6 and the 4. And then on the next row, which would be wrong? The 10, the 10 and the 5. And then on the next row, the 15, the 20, the 15 and the 6 would be wrong. The whole thing becomes wrong, yeah.
It's a arrow subtree.
Say again?
Subtree.
Subtrick?
Subtree.
What do you mean?
If you regard this triangle like a tree,
Oh yeah.
and you will find it's a arrow tree.
A what tree?
Arrow tree.
An error tree?
Yeah.
I don't know this term. What's an error tree?
It happens in the black and the red tree.
No, I don't know about this.
It's the one kind of the binary search tree.
Oh, it's like a search tree.
Yeah.
Oh, okay,
And
okay.
we can fix it very fast.
Oh, okay, okay. I'm not so knowledgeable on search trees. I only know 3 or 4 different types of searching, so I didn't realize you could have a search like this. Okay. Did you write that down?
Yeah.
So this is a way in the exam you can know if you did this right. Because sometimes in the exam they might say, draw Pascal's triangle up to row 6. Now if row 6 is right, then you know that row 5 must be right. Yeah? And if row 5 was right, then it was only because 4 was right, and so on. And how can you know row 6 is right? Well, the total of row 6 should be 64. You see? So then you can know in the exam that you've done this triangle correctly, which is nice. So what we'll do next is how we can use this triangle. What's its applications? Okay? Did you write that triangle down? Because we'll need to use it in a moment. You have that? Yeah? Okay. So what's great about Pascal's triangle is it lets you expand quickly. So for example, suppose I ask you to do something like expand, let's say x plus y power 4. Okay, so watch the steps. First step, you go to row 4 on the triangle. So looking at row 4, tell me what the numbers are. So, okay, so what you do, you write down 1 and then xy plus. Right, what's the next number? 4 xy plus. The next number? 6 xy plus 4 xy plus 1 xy. The only thing that's left to do, that's missing, is the powers. How do the powers work? Again, it's pretty straightforward. You choose to start at x or y. It doesn't matter which. So which do you want to start with, x or y? Well, I might as well start with x. So you start with 0 and count up. So that's x power 0, power 1, power 2, power 3, power 4. And then the y goes in the opposite direction. So if you start with 0 here, then you start with 4 here, 3 here, 2, 1, and 0. Let's clean up the answer. What's x power 0?
1.
Times 1? So this is just y power 4. And x power 1 is x. So 4x y cubed, 6x squared y squared plus 4x cubed y plus. See, it's nice, the triangle. Lets you expand quickly. Amazing, huh? Right, we'll do more examples if you can write that down. Now, the next example I'll do is I'll put numbers on the x and the y. And then the example after that, I'll put in a minus. Yeah? Yeah, do another example when you're ready. Okay, you got that? Yeah? Can I scroll down, Marwan?
Yeah.
You sure? Yeah? Bello? Yeah? Okay. Right, so let's do an example now where we have numbers. For example, 2x plus 3y cubed, we'll say. Okay? So, what row do we look at in Pascal's triangle? Row 3, third row. Right, what's the first number? 1. And then you have to write down 2x, 3y. Next number? 3, isn't it? 2x, 3y. Next number? 3. 2x, 3y. And then the last number? 1. 2x, 3y. Squish. Okay. Now, where do you want to start? With the x or the y? Let's start with y this time. Why not? So, what power here? 0, 1, 2, 2, and 3. And let's start. The x goes opposite. 3, 2, 1, and 0. Okay, so be careful here. 3y power 0 is 1. And 1, 1. 2 cubed, 8. 8x cubed. Okay, plus. Right. Now, 2 squared, 3, 1, 3. 4 times 3. Good. Don't think too hard now. And 12 times 3? 36. X squared y. Okay. 3 squared? 9. 2, 1? 2. 9 times 2? 18. 18 times 3? Oh, 50 something. 54, yeah. 54 xy squared. Okay, and the last one. 2x 0? 1, 1, 1, 1. And then 3 cubed? 27 y cubed. Yeah?
Even after you use the power, you still like put it there.
What do you mean?
Like for the first one now, 2 cube. Like
2 cubed, yeah?
After everything, you still put the cube up there. Like
The 3 on the x? Yeah, so what has happened here is the cubed has jumped onto the 2 and onto the x.
Okay.
Yeah. Yeah.
So you can use this like in the exam anyway.
Oh yeah, in fact, sometimes the question will say expand by using Pascal's triangle. And so you will have to draw the triangle in your answer to prove that you've used Pascal's triangle. Which isn't that difficult to draw. And they never really go past row 5 in the triangle. Row 6 maximum, in my opinion. Yeah? No? Did you copy this down? I see some of you writing. Yeah? Okie dokie. You got that? Now I'll do another one, but now that you've seen 2 examples, I think you can at least try it before I do it. I want you to see what you make of this. I'll stick a minus in now. 2x minus 3y power, we'll say this time 4. Just have a go, see if you can figure this out before I do it. How are we doing on this one? Yeah, you got it, you think? Nearly, okay. Got it? Oh, sick. Good dose of physics homework will cure that. You finished it? Yeah. Think you're right? What did you do in EAP yesterday?
Prepare for presentation.
Oh. Okay, that's not exciting. Or is it? Did you all pick your presentation topic?
Good.
Yeah. Nice. Anyone else doing physics?
Same groups.
Oh, you're in the same group?
No,
No.
not the same.
We are groups like
Oh, sorry. You're in teams for the presentation, aren't you? So what is your topic?
Newton's three laws.
That's interesting.
Ask them.
No, it's interesting because usually the EAP teacher asks me each year, what topics can the students do in physics? And I normally say, oh, they can do any topic. I don't mind, any topic. Except Newton's laws.
What?
Sorry, are you going to be there?
Sometimes I am, and sometimes I'm not. I'll leave you guessing. Why? Because it's so boring. Because it's so straightforward and...
Yeah, I want to do AI, but Neil encouraged me to do Newton's third law.
Wait, this was Neil's idea?
It's our idea, but Neil recommends to do that.
Neil. Newton's three laws are so uninteresting for a presentation, no? Do you like them? You see,
I think because he said it can be more academic.
it can be what?
Academic.
Newton's three laws can be more academic. You see, he doesn't know about physics. I like gravity. Dami. So what topics are you going to cover?
Just
So just the power
universal
four,
law
it's
and
The what?
The other way.
Yes.
I'm doing the history. He's doing education and
Yeah, it's minus y, yeah.
the universal law
Oh, okay, nice.
and some physics.
Is anyone else doing physics?
Yeah, Corona.
There's no
It's physics.
Corona? The sun's? Hang
Biology.
on. Sun's corona or
No.
eye corona? Or what?
Coronavirus.
Disease.
Coronavirus.
Coronavirus. That's like biology.
Oh, that's not physics. For sure. Right. So did anyone figure out the trick here? I think what you should do is change this into first 2x plus minus 3y power 4. And what's the coefficients for 4? 1, 2x minus 3y plus 4, 2x minus 3y. What's next?
6.
Plus 6, 2x minus 3y. You don't need me to write the rest, do you? You have the idea. Plus ... And did you start with the x or the y? So you went with 0, and this one was 4, 1 and 3, 2 and 2, etc. So what's the first one? Is it 81?
Minus.
No,
No,
plus.
Yeah.
Y4.
Yeah.
Then the next one is a minus.
Minus 216.
216 xy cubed. And then the next one is a
Plus.
plus.
Plus 216 x square y square.
And then the next one back to minus.
Minus
Minus
6 x cube y.
X cubed
Y.
y. And then the last one is plus 81. No.
No, 16. 16.
16
cube 4.
Y.
No,
Oh,
X.
X 4.
Yeah.
Yeah. Pretty straightforward, right? Nothing too exciting, right? Let's see. What would be a good question for you to do?
What's the confusing question can be a tricky question.
Well, actually, hang on one sec. Sorry, one at a time. So back to you. What were you asking me?
What's the tricky question?
What's a tricky one?
Yeah.
Okay, the hardest one I've ever seen in the exam was this one. No, it's not as bad as it looks. It's not as bad as it looks. I'll do a smaller version for you, like cubed. Okay, so what's the first number? 1 x minus 1 over x plus 3x minus 1 over x plus 3x minus 1 over x plus 1x minus 1 over x. So we'll go with 0, 3, 1, 2, 2, 1, and 0, 3.
Yes.
So what would the first one be?
Minus 1.
Minus 1 over
6 cubed.
x cubed.
X.
And then the next one would be plus 3, and this is x over x squared.
Over X.
Yeah. The next one is minus 3 x squared over x. X. And then the last one,
Isn't that 3 over x squared?
no, but don't forget the x on the top.
Oh yeah, it comes.
Yeah. And then the last one is
X cubed.
plus x cubed. Okay.
Modify the
Can you-
denominator and just have it without fractions. You can like make it one denominator.
Oh, they wouldn't expect you to do that. You want it like all over x cubed.
Yeah.
Yeah, no, they wouldn't expect you to do that, don't worry.
You can collect like terms.
No, you can leave it like this for this one.
No, I mean
What?
like at the start you
At
can
the
like
start?
multiply 1 over x. You can multiply x multiply it by x over x. Then you won't have a fraction.
Oh, back it up there. You want me to do what at the start?
Like multiply x.
This line.
No.
This line.
Yes.
The whole.
Multiplied by.
No, like inside.
Oh,
Yeah, like it become easy.
inside, yeah.
Multiply x.
Multiply by x.
X over x.
X over x.
That'll be like x minus 1 in the numerator.
Oh, I see what you're saying. So you want me to change this to x squared minus 1 over x.
This
You
how
It's
can,
cubed.
you can split it then.
Oh, is this better?
this how
Yeah.
X squared minus 1 cubed over x cubed.
Ah,
Yes.
Is this an improvement?
no.
Probably not.
I mean, it's not wrong.
But it's how you
Nah.
So like,
Nah. Yeah.
Yeah, so for the first example that you did,
Yeah.
so for this one you just like multiplied x and minus 1 over x.
Yeah.
But for the first one you didn't multiply
For which one? This one?
the first example.
The very first example,
Yeah.
which was what? This one? What did I not do?
So you didn't like
Shh, hang on, I can't hear him. Guys, Marwan.
oh x plus 3, I thought it was x plus 4.
Huh?
looks how
I thought it was x plus 4.
X plus 4?
Yeah.
Where?
No, I thought the question was x plus 4.
Oh! No, that's a Y. Yeah. X plus Y. Did you not think it was strange that the Y suddenly appeared if it wasn't in the question? Yeah, that was a bit interesting, wasn't it? Yeah. All right. Do you have that written down? Yeah, and the last one. So, Marwan, you were asking what's the trickiest I've ever seen in the exam, and it's this one. But I would say, I mean, I think I've only seen this once. Most of the time, they give you a question like this in the exam.
It can be like the bar you don't know, it's like maybe y and you find the y.
Oh, don't worry, they get harder. That'll be a different lesson. But just for Pascal's Triangle in the exam,
Okay.
it's like this. But yeah, sometimes there's something missing here. Like maybe, for example, it's like px minus 3y power 4. And they might ask you to find the p. But that's later. That's later. Okay.
I've not copied the
You need to copy that? Okay. Right, this one?
Yeah.
Okay. Can you write that one down? Oh, are you okay, Ming?
No.
Oh dear. Did you take medicine? What did you take?
I brought some medicine from
Lamps? Oh, Chinese medicine. Oh, okay. Did you write this down, Dami? Did you write this down? You don't need to write down Abdul Rahman's red part. Just the black part, okay?
Yes, sir.
Right, you got that? Yeah? Okay, good. Now, I'll give you your homework to try. Okay. Yeah, no. I'm just thinking about something else right now too. There's like 10 things in my mind right now of things I have to do and things that need to be taken care of. I'm still, oh goodness, alright, hang on. Let's see. I like you to try to do the, well, I mean, David, if you want to do every question, I'm not going to get in your way. In fact, I encourage it. We'll say 4 A, B, C, D. There, look, I'm being nice. Only 4 questions, okay? Well, no, actually, I don't want to be too nice. And E. Right. In the tutorial. Yeah, remember? I said last Friday, you asked me, can I do this question? And you asked me after the tutorial. And I said, I will do it in the next tutorial. And the next tutorial is when? Friday.
I don't think we have a tutorial this Friday.
We don't?
You have in the morning.
Okay.
Yeah.
Why would you think we don't? Something going on Friday?
We have a schedule.
I'm like-
Friday afternoon we have like science lab,
Chemistry
chemistry
lab.
lab,
Oh.
and then we change the class in the morning.
So, do we not have, we have class in the morning instead? Do we usually have it in the morning?
No, it's
No,
like we have
in
one
the
class in physics in the morning. I changed to Thursday afternoon, and then 2 math move to the
Yeah.
morning.
Math was normally the last thing on Friday.
Oh, I see. But now it's in the morning. Double maths, as normal.
Yeah.
Oh, look. Okay, well, look. Guys, can we just go back to discussing about the physics? As an idea, if you feel like the maths is okay for the week, we could always turn the maths tutorial into a physics tutorial. No, you're not happy with this idea. Well, it's worth keeping in mind. That's always an option on the table. If in a particular week you feel like it's better to be doing a physics tutorial instead of a maths, you know, because look, the thing is, one advantage of having the maths and the physics teacher as the same teacher is you do 6 plus 6, okay? But there's no reason to do, or we could do something like 5 plus 7. You know what I mean? Like maths, physics, okay? I do apologise. I probably seem quite cranky this morning, but I'm really trying to figure out what can be done to help. So an idea jumped in my head that we could actually turn the maths tutorial into a physics tutorial too, if you feel like that would be better. But maybe you like having the maths tutorial.
I don't mind.
You don't mind? Friday, yeah. Do you know what I'm saying? You could make the maths tutorial a physics tutorial, but maybe you would prefer to keep it as a maths tutorial.
Maybe one maths, one physics. This is two.
But then one maths.
Tutorial.
One physics. This is two maths. Yeah.
Oh, we might fall behind in the maths. We need to turn the maths tutorial into a physics tutorial. I don't really want to turn a maths class into a physics tutorial, unless we go a little bit faster in maths, which is also possible. No,
Speed is okay.
the speed is okay for maths. Yeah, okay, right. And also, are you guys working together in groups for your physics, or are you all working individually?
How?
Are you guys not friends with each other or something?
No, sir. Yes, sir.
Like people
We don't stay like close to each
yeah,
other.
and then people do different things at different times.
We're not staying like after school. We're just like.
So we would like sit
After school, you're chillaxing.
No, you don't give us that privilege.
But I mean, you can always,
Assignments every
for
day.
example, one of yous could go to someone else's house and study together, right? Like, don't some of you guys live on campus or near campus? Huh? But near campus?
Yeah, near.
You're near campus?
Yeah.
How far away?
10 minutes.
10 minutes.
Actually, 8.
So like, you're 8 minutes away.
Yeah, we're in the same place actually.
You're in the same place,
Maybe the second
and you
floor.
felt no need to study together.
I actually asked him once.
You asked him, and he turned you down.
I didn't tell you don't never keep.
In a way.
Oh, he stood you up. Now the truth's coming out. Right. Well, look. Anyways, you can work on the maths now, but if you have some ideas, you can. If you can think of something, you can email me. And remember, the maths is flexible too. If you need to sort of shift the time from less maths, more physics, but then that might mean going a little faster in maths, which I have to work out. Okay. So anyways, you can try these for a few minutes.